Or is that just my eating habits? All right, anyway, it's one or the other, or a combination of the two. All right. Okay. So we started with this just to start our notes. So we did a little AP video about it, got a little too far into what a radian measure is, which I can kind of reference today a little bit more, but it's not the point of this. Really, the point of this is SOHCAHTOA today. And then the idea of what the AP video did. They did talk about standard position. Okay. So I'm going to do a couple things though. I'm going to add some measures here. So wouldn't you agree that this is greater than 90 degrees, right? Okay, so now I'm kind of circumventing the situation, but you can go ahead and read this. And then I'm going to give an argument for why a coordinate plane. Why I remember after like 2, 3, 4 weeks of doing what I call coordinate plane trig, which is brand new for all Math 2 and Math 3 students, not Math 3 honor or Math 2 honors. You Math 2 honors people, this was a big component last year. And I actually even leaked in the radians. And I think a couple of the other teachers might have, and some did not. So some of you Math 2 honors may not have seen a radian measure. That's fine. You'll be in the even situation with the Math 2 and Math 3 regular students. But standard position is just, why coordinate trig? Everything's coordinatized to organize the world for us mathematicians or people that try to figure out stuff. Earth is. What's the coordinate plane of Earth? I'll give you a hint. It starts with 2 L's or 2 words that start with L's. Anyone? Longitude and latitude. That's basically just a coordinate system to find positions on Earth. Okay? So engineers and many other people that use trigonometry in their world like to have it in a coordinate plane so they can locate things. It's locators, and this is a true statement. I don't know what else to tell you. That's why we like putting things in a coordinate plane. It's a way to figure out where things are relative to others. And believe me, high-end engineers or astrophysicists use 3D coordinate planes. There is actually an X, a Y, and a Z axis to compare to the three-dimensional world that we live in, and so on and so forth. So you're just in the 2D right now just to get, the basics. And then if you proceeded on to some more complicated stuff, you'll see it. And it really can be reduced down to not being so complicated. But anyway, so I'm going to make up something. I'm going to say that's like 115 degrees. A reasonable estimate. If I got that protractor out and measured it, we'd be close. Actually, probably a little bit off. It's probably more like 130 or something. But whatever. We're making an estimate. And then that's positive. So what I want to do is go over to this one and use green for negative just for coding. This one right here, she didn't say this in the video, but if positive is counterclockwise, then when I go this way, that represents a negative angle measure. That looks like the same opening, but we're now in quadrant 3. So if I measured that, that might be 115 degrees, but we have to say it's negative. Why? Because you're in a coordinate plane, and this is just a way of locating. If I go clockwise, I put a negative on it, so I tell everyone else that looks at this angle, I went in a clockwise instead of counterclockwise direction. That's just what it is. All right, but then you know what I'm going to do? You want to get nuts? This really isn't getting nuts, though. Let's name that angle measure. What do you think the relationship between the green and the red angle measure is? They both would add up to, anyone? See, no one answers. This is why I'm about ready to get out this calculator. Your non-answering of an easy question makes me think you're licking the walls because you're not paying attention. So I almost want to get the calculator out and start collecting groups for answering. Forced answering. So there it is. You've been warned. Oh, my fat face is in the way of reducing this. All right, there we go. All right, let me do this too. Why do you put your face up there? Just so you know we're live in class. I can't show the students, though, because they'll sue me. Oh, believe me, they're coming after me, trying to cancel Mr. S. They've been trying for years. All right, anyway, so what's this angle measure? I can't do math right now. What'd you get? Thank you, ma'am. 245. Wrong, ma'am. Oh, so now she's not going to want to answer anymore. Maybe that's why they don't like answering. Because what's on that measure? What kind of thing? A negative. All right. Good job. But you were just telling me the actual number. So I just, that's my way. I like doing that to people. All right. She's shaking her head. Yeah, you do. And then this is positive 245. So I figured these openings were the same, but one's negative, one's positive. So you land in different quadrants, and keep that up. This is going to be huge tomorrow. This is really the backbone. This is part of the backbone combined with knowing what the sine of 30 is. By the way, what is the sine of 30 degrees? And if you don't know it, you make me sad. 1, 2, 3, go. 1/2. If you lock that in, and the other ratio for 30 and 60s and sine and cosine is √3/2, right? Then you'll be able to figure out what's sine of 30, cosine of 30, sine of 60, cosine of 60. It's a huge deal. Now I'm going to throw up on my computer and it might electrocute me if you don't know this one. What's the sine and cosine of 45? 3, 2, 1, go. √2/2. And if you're sitting there bamboozled, how do they know that? The last 2 days, standing up on the boards and filling those out, were you sitting there like this doing nothing as your partner did something? These are the things that, what did you do when you did your homework? Okay, now he's getting into this thing, and getting all worked up. Okay, but again, these are the things that are going to have to be memorized. I implore you how important it is to get those locked in. All right, let's speed this up. What's 60 degrees? Right here and about right there. But again, standard position means you have to start at the positive x-axis because that's the rules. Somebody made this up. Someone locked it in as this, and everyone's like, okay, yeah, we'll do that. All right, and that's what you got to know. What's negative 90? Well, I have to start here, but then I have to go clockwise. And then that's right here, so that's negative 90 degrees. I really shouldn't have to cover this too much more. Hey, what's this angle measure from here to here? Everyone say it or else I'm getting a calculator out and there'll be vengeance. 180. So where does 240 land? What quadrant? Remember, 1, 2, 3, 4. So everyone should know that 240 lands right around here. And then what's this angle measure right here, which is going to be called something tomorrow? What does that measure? Okay, what's that little one right here? Just to know that. What's this little one right here? Don't give me the calculator out. Here it comes. Okay, what does that angle measure from that 180 to the 240? 60. What are these things? Holy cow, look at those answers. All right, I was making a point with the BCers about M-totes. I'm sorry. Okay, and then 570. Oh, what's 570? Hey, you do this in Walmart's parking lot if it was snowing. What do you guys do in the parking lot illegally? Donuts. And then you imagine eating a donut while doing donuts? That'd be great. But that's donuts got my mind now. You don't call it a donut though. When you do a full rotation, what do you say? Hey, I just did a what? 360. We're gonna change that tomorrow, and then you're gonna be really cool with your friends. But we'll have to wait for that. Isn't that 360? Oh, son of a, I can't do this. I didn't ask for this. All right. What does that measure, everyone? 360. So then how much more do I have to go? We got to do some math, like maybe what? Subtract 360 to find out where this lands. All right. So then what is that? Oh, I can't do math. 210. Where does 210 land? Where does 210 land? What quadrant? Third, because there's 180. And then how much more just for giggles? This is going to be important for later. So that's a 30. I will leak this out. That's called a reference angle. And hey, what's the sine of 30? A half. Guess what? When we take the sine of 570, guess what we're going to get? Say that fraction again. 1/2. And this is your world tomorrow. This is why if you don't know what the sine of 30 is, because you're licking the walls and don't participate, don't do your homework and copy and whatever else you do that you don't learn, you're doomed. Because that's the backbone of everything that we're going to be doing all the way till May. Make a commitment, and it will be easy. Did I say good morning? I feel like I'm getting a little rough right now. All right. Hey, by the way, what do you think that measure is? Now, this is called a coterminal angle. What's co mean? Cooperation. That means you're working together. So the same. So what does that angle measure? Well, we just said this was 210. So what would this be? First of all, negative. Anyone? 1. Anyone? Don't get me yet. No, don't make me. Okay. Negative Here's what I use to pick students against their will. And then they're going to try to cancel me. You can't do that. I'm allowed to sit here and do nothing and lick the walls. It's my right. All right. All right. What's the answer? Negative 150. Okay. Got it? Oh my gosh. We should have a party. I just realized everyone's here. It's a miracle. Let's see if this happens tomorrow. Or no, the rest of the day. Are you okay? Oh, I just turned to the student. She was giving me the stink eye. All right. All right. So now, remember, the one thing I like about the video is a circle. And then there's a bunch of questions today about, hey, point P is on this circle with a certain radius, and it's an endpoint that this ray passes through. Okay? So got it? So now what we can do is coordinatize this trig. And then I'm going to create a new little thing for trig for you to memorize. And I'm going to stick with it, even though the other teachers in my commune, I guess, don't really like, and I don't care, because I feel like we need it. So do you realize when you do a coordinate, you go like this? You move this way. And what coordinate is that? What coordinate is that goes right or left? X. So put that down. That's X. And then what coordinate is that? Y. And then what is this called for the circle? What is that called for the circle? The radius. And we're going to mark it, dude, as R. Okay? And then here's theta, the theta in question right there. It's the one that's, remember she said about the important, not the importance, but she said the angle's vertex is attached to the origin, and then she rotated it to make the initial side on the x-axis. This is referencing the AP video, which you, if you were absent, which no one is in first hour, all right? It's a big day. I forgot what I was saying. I got hooked on absences. But on the AP video, you can watch it if you're at home, if you're in second, seventh, and missed today. But she does reference what standard position is. Okay, so what sign? What sign? What sign? Opposite over hypotenuse. But look at this. And actually, I should have color coded this. What is the opposite side? What coordinate is it? What coordinate is it? Y. And what took the place of the hypotenuse? What letter? R. This isn't always. Sine, when you're in a coordinate plane, will always be y over r, because that's how you draw this reference triangle, is what I like to call it. You draw it as if you do a coordinate. You move right x and up y, and then you snap back to the origin. That'll be called r, because there's some sort of circle that we're moving these points around. You know, and this is a valuable thing that we do. And then you math tours, we eventually deal with the unit circle where r is equal to 1. And that's like the most powerful thing that we have to learn throughout the year. So Monday and Tuesday were buildups to Friday, when we start calculating values in the unit circle as we move around, move points around that unit circle. What would the trig be of those? And then you're going to find in all 4 quadrants, there's a 30-degree reference angle. What sine of 30? See, again, if you don't know that, how many times have we mentioned it today? You really would have to be a wall licker to not know what the sine of 30 is, even today, because we've mentioned it like 4 or 5 times. And I don't care. I just know what happens and why we fail. There's something going on. We've got to start doing the right thing. All right, and then what's the cosine of theta? Boom. Hey, what's the adjacent side? What letter is it? It's x, and then what's the hypotenuse again? So cosine's ka. Every single time you draw this correctly, the adjacent side is x, and the hypotenuse is replaced with r because we have some circle thrown in there. And then what's tan? Not to go back up there. Oa, toa. And then what's the opposite side? It's the same. It's y over x. Same thing. Opposite's always y. Adjacent is always x. How's that drink? Good? That's not a lockboard, right? No. So, hey, write this down. So wrong. I need some more space. Write this down up here. So, ka, toa. You're going to turn this into sir, kixer, ticks. So let's all say it together. Sir, kixer, ticks. That's our new acronym when we're in court. Are you okay, Abby? You're rolling your eyes. Sir, kixer, ticks is our new acronym when we're dealing with coordinate trigonometry. I just doubled coordinate trigonometry, basically. All right. So anyway, you're going to need this, by the way, because there's not going to be a triangle that you won't see the opposite or hypotenuse or adjacent. It's when you're on an actual axis. Were you in Math 2 honors last year? You're a senior. Were you in it 2 years ago? Oh, okay. Oh, no, then you didn't see it because it's semester 2 that we do this. Okay, so go ahead and read that question real quick. What was that? Because I asked people to read, and then this is what they do. 1 ceiling tile, 2, 3. Look at that thing. It's moving. This is a distractor. That's because we have a wind chill in here. See that thing moving? So every time I walk in here, A, it's cold, and B, there's a breeze that hits me in the face because that thing in the back won't stop blowing. This feels awkward in the movie. 14, 24, so I have 20 minutes. I'm okay, don't worry. Thanks. A concerned student. Did anyone answer it? No? A, B, C, D. This is a very AP-like question. You know what I would have done, I would have done this. What letter is that? What letter is that? X. What letter is that? Y. And then what letter did I just call this because it's a circle? R. Oh, wait a minute. What is R? And this is what you have to focus on this whole day today. What is R if this goes from here to here to be 3? What is that? Then what is this distance from here to here? 3. Okay. All radii are equal in one circle. All right. Good. So then which letter is correct? Which one appropriately shows what the cosine of theta would be? A, x over 3. Okay. There you go. Sir kicks or ticks. But you could say, okay, fine, that's the adjacent, this is the opposite, this is the hypotenuse, and you could still cheat and do SOHCAHTOA. But I'm telling you in the future, this isn't going to work because certain trig values, there is no triangle. If you have no triangle, you have no opposite and adjacent side. And that's going to be a problem. That's why I don't know why the other teachers don't acquiesce to like that kind of thing, because I think it does help if you just learn that. All right, they draw this. Hey, I don't like this question, but it's trying to incorporate a line into this, which Mrs. Cooper is really awesome about this. Tangent actually can be expressed as slope. And I'm going to actually kind of show you on this, even though this is not a trig question. They're trying to get you to understand this coordinate here. What would this coordinate be? So basically, if you read this, this is x comma 15. You need to find what x is if you read this. But then they say this line has a slope of -5/7. Now, I know I can't attach this quite right to here because this represents 15. I'm sorry, wrong. This represents x. This represents 15 high. Do you see a 15 in this slope? Yes or no? Do you see a 15 in that slope? The answer is actually what? No, but you see something that's a multiple of that, right? -5. So realistically, what's happening in this, the slope is down 5 over 7. I could put a little triangle in there that represents that this is only up 5, and isn't that left 7, right? Okay, I'm doing this a little different than last year. I'm just trying to climb into your head how they, put this together here. And then what they actually also ask you to find. Oh, do they ask you to find that? No, I'm going to go ahead and do that anyway. We're gonna find what x equals, and then we're going to say what s's coordinate is. All right, and we're going to do that, and then that really is almost the notes for the day. Like it really is close. And then we have different iterations of the same thing. Not really. We got some decimal stuff. I should probably tell you to get your calculator out, I believe, but let's see. Okay, and then really what this is, these are similar triangles. Basically, all I need to do is, okay, so -5/7. By the way, what is slope? Rise over run, which actually could be considered the difference in y over the difference in x, right? And that's why Mrs. Cooper always calls tangent what? She calls tangent slow. I just said it already, slow. And I'm going to do that again this year. Not again. I'm going to kind of incorporate a Cooper idea. All right. And then give her credit like the rest of my career because she's done this year. She's retiring, so I'll try to mention her name. All right, so then what is this? This is rise, so this should be 15, and then this should be the unknown x, and then I could just crisscross multiply. So I did this last year. It's really, or you could just multiply 7 by 3 and really understand that. So, and that's actually the answer. -5x equals, I'll get this, 70 and 35 is 105. And then when you divide, it most certainly should be negative. And I believe it's -21. So the x coordinate is -21, 15. And you better know it's negative. This is about our quadrants, left and up. And that's what you're going to find out. Now your trig is going to have negative numbers. Why? Because of coordinates. You're in coordinate trig now, so you have to be aware of that coordinate. Okay, guys. Now here's some new stuff. Okay, we'll leave it. Ooh, oh, why didn't I get an arrow on that one? The inconsistencies drive me nuts. If you reflect this over to this side, and this is now -21 this way, then what should this distance be from here to here? And the answer is 21. And is that positive or negative to go right? That's positive. And then this should be the same distance down as this is up. So what would that be? -15 down. So the coordinate of S is 21, -15. And then these angles would be the same. These are called reference angles. They would be of equal measure just from that nearest x-axis. That's why we're going to have to use the term reference angles a lot. All right, what is that little reference angle within that, what's called a reference triangle, actually? All right, but we're leaking ahead. We're leaking into the 2 days. So, that's what we got going on here. All right, how do you do this one? Let's speed this up. What's that number right there? Look at the coordinate and tell me, what's that number right here? -3. What's that number? Why is that the sound for coordinate drawing? What's that number? 1. How do you find this? How do you find that? Starts with a P, and I wore the shirt yesterday. Did you see that shirt yesterday? It was Einstein, and then it was Pythagoras fighting after c squared. And then Zion, 7th hour, I go, hey, does anyone know Zion? She's in the movie. They go, who is this? And she goes, Jesus. I'm like, no. And you can't say that in a public school. So I had to suspend her. Anyway, so -3 squared is what? Okay, see, again, nobody answered. Just like, the answer was 9. What's 9 plus 1? Get your calculator out. 10, because apparently not answering means you don't know. Oh my goodness. All right, and then that's root 10. And then I'm going to tell you right now, the I will do rationalize, but the AP exam doesn't really care, sir. But come on, we can play it. We can play opposite over hypotenuse. So it's 1 over root 10. And then just for, this is as hard as your rationalization is going to be. I know in Monday's lesson, I probably went a little too far into rationalizing. Just, be able to do that. Just like root 2 over 2. So I get mad. People don't know sine and cosine of 45 is root 2 over 2. That's your ratio. tan of 30 is not, don't do 1 over root 3, although it'll be okay. It's root 3 over 3. That's the two rationalizations. Well, there's a couple more when we get into secant, cosecant. But anyway, cosine is adjacent over hypotenuse. And then you should become a robot and say, well, I know when I rationalize whoops, wrong. Apparently I don't know. The 10 gets free of a radical, and then the radical goes up to the top. So that's a robot. Like, I don't know how to rationalize, but I've seen this over and over again, and this is the pattern that develops. I don't know what to tell you. And then tangent is negative 1/3. And now I want to speed this up because it's really established, except students hate when they deal with decimals, as said in Incredibles 2. Anyone ever see Incredibles 2? Hey, a couple of people actually watched a movie back in the day. What's he doing that for? Okay, what's this coordinate? Which one is this? Negative 0.65 or negative 0.76? It's negative 0.65. And then this is negative 0.76. And by the way, put this down. This is called what you're going to be dealing with in Friday and then almost forever after that. The unit circle, because r equals 1. And that's a nice thing. And that's what they really focus on. Not today. You have a bunch of different radii today. All right, so let's go. What is this? It's negative 0.76 over 1. Hey, that's negative 0.76. What's the cosine of alpha? That's just alpha, by the way. Get used to these Greek letters. Beta, alpha, theta. That's what they use for angle measures a lot. So notice I haven't talked about a radian measure. I was surprised. I forgot video 1 didn't really. But I like the point on a circle. So they didn't introduce that. We're doing coordinate trig now. All right, and then I didn't do that wrong. Yeah, no, I didn't. So it's negative 0.65 over 1. That's the glory of the unit circle. The radius is 1, so this is cosine, and this is the sine, as long as the radius is 1 in a unit circle. That coordinate represents cosine comma sine. Now I see someone bebopping on their calculator because hopefully they're doing this. 0.76 negative divided by 0.65 negative. And then you get a decimal. We're not teaching how to type on a calculator today. What'd you get though? Huh? Definitely 1 point something, because right? Yep, 1.17 apparently, he said. Oh gosh. The 6 trig. I hate when they do this and don't give you these ahead of time. And notice I said 6. So we're going to go ahead. And you know what we're not going to do because of time? We're not going to simplify. We're just going to go ahead and write them, and then you should know what to do after that. Sinus so, who's a hoe? You're going to get in trouble, Mr. S. I'm just trying to get the kids to memorize. Whatever helps them. And if hoes help them, then that's fine. What? All right, so we make a little joke. Sinus so, cosecant's a hoe, so therefore they never forget who. So then, okay, then secant goes with cosine, because sine goes with cosecant. And come on, cotan goes with tan. As far as the flipping. And we're at, okay, so you got to read this. And then maybe this would be smart. Okay, so this is 2.6. This is negative 5.4. And then this is a radius of 6. So that's a radius of 6. So now I can play. I'm allowed to play SOHCAHTOA. I have a triangle. Oh, and by the way, what's the angle? This is the angle. Sure, that's what alpha is. But then what we like to call this, I'm going to zoom really in on this, and this is why I didn't give you 2 papers on one side. This is called alpha prime. I might as well bring this up. That's called the reference angle. Looks like a fish with a little mark on it. So theta prime would look like this, theta with a little tick mark on it. That's what the reference angle thing is. But what I'm getting at is this is what you play SOHCAHTOA with. Opposite, adjacent, hypotenuse. Got it? That's called a reference triangle. This is going to be huge. And then I only feel like doing like sine and I mean, you should be able to get this. This is negative 5.4 over 6. And then, cosecant, you know what cosecant is. But that's what that means. It just flips. And then cosine is 2.6 over, and then feel free to type it on your calculator what that decimal is. And then secant is just the flip. So even though we're not doing that now, you won't have these 3 on the rights on your next quiz. it's coming up, so we might as well just reference it. We do disagree a little bit with the order of AP. I think we should be doing all these at once, these calculations. They do kind of a weird thing with it. That's okay. Everything else has been pretty awesome. Really transformed the class. All right, I'm not going to do this one. I just want you to become a decimal fraction person. What's 3? What's 0.3? How do you read that? That's 3. What position is this in? I think students don't know this. It's in the tenths. There's fourth grade for you. So this is 3/10. And then guess what that is? That's y. Fine. That's the opposite side, which is always y. I'm going to really try to hammer down cirkicks or ticks, but you can do this. Sketch a picture, leave your answer, second quadrant with sine theta. Find cosine and tan. Fine, I better do this. By the way, where does it say it's in? Where does it say it's in? Second quadrant. Let me color code this. So here's your reference triangle. It doesn't have to be to scale. And what I know is, I don't know the x because this is the y, 3 and 10. And 10 is the r. Or 3 is the opposite of this angle measure. This is the angle measure, but this is the, let's call it theta this time. Oh, it is theta. So this is theta prime. And then I do want to get to that last one, which I skipped last year. Couldn't care less that we only have 6 minutes left. This is setting up a lot. How do I get this missing side? The p, anyone, the p, anyone? The Jesus formula. No, Zion, good Lord. All right. Tell Zion she made the notes today. Does anyone see her today? No one? Do you? Tell her she's talked about 10 squared. I just want people to be famous. 10 squared, because I get 3 views a day. So, did you hear that? But by the way, this is negative. Why? Why? First of all, I made a boo-boo. That's plus minus, right? When you square root. Why is it minus? Because I went which direction? Which direction? Left. And then those are the 3 values you do cirkicks or ticks with. Or fine, ka, toa. Got it? And then you write those ratios just like we did up here. It's all the same. And then this last one's all the same. Okay, but what is going on? AP. AP is going on. So you know what I'm going to do? I'm going to answer all of these questions just right up here. So what we have is a square, and then what we have is symmetry. So if this is x, and then this is y, then what would this coordinate be? And what would that coordinate be? Okay, what does it mean to go left? What kind of x value do you have? Negative. So this is negative x. What kind of y do you have when you go up? Positive. So this coordinate is negative x, positive y. Remember that. This is why we're going to get negative ratios. There's more to it down there, but this is really what I want to cover because we're short on time. What does it mean to go left and then down to get to this position? It did it again. Okay, I guess I like that. What does that mean? What kind of y is this? Negative. So in this coordinate, you're going to have a negative x and a negative y. Right? Symmetry. This is what's happening because you're doing the same distance moves. What happens when you go this way for x, but then this way for y? Then it's positive x, negative y. Then I think you can answer all the rest of the questions there. And then I think this is good for later. I think we try to do too much and throw too many things at you. It is a connection, but we're going to hit that connection later. And then it does say find the sine of the angle that, okay, you can put your stuff away, but I will finish this off. What's the sine of angle S then? Sine is, remember, these are all R. And by the way, let's write this down. Oh, I already put my notes away. R is always positive. I'm going to say this probably the next 5 set of notes. The only reason X and Y are negative, it's what quadrant you're in. It's like just a locator. If I have a negative X and a positive Y, ooh, I'm in quadrant 2. If I have negative X, negative Y, ooh, I'm in quadrant 3. R is always positive. So anyway, what's the sine of angle S? Well, sine is Y over R, but this Y is negative. So you will have a negative ratio. Cosine of the angle who intersects at Q. Cosine of Q. Sorry, I was supposed to put S up in that top one. Cosine of S. Let me change that. So sine of S is this. Cosine of Q. Q is up here. That's a negative X over R. Cosine's kicks her, but X is negative. What's the tangent at angle R? I love this. Then you're going to find out why we have these bottom questions later. Tangent of angle R is a negative Y over a negative X. Hey, what's a negative over a negative, everyone? So you will result in a positive ratio for this one. And that's just a big concept right there. That's will help us as we move forward. All right, so last year, I don't know why I didn't do that example, and then I was short when it came to the review because we had a lot of questions like this in the review. So I wanted to clean that up for you. All right.